All right, so this is the trapping rain problem. Uh, so you're given an input, an array, and the array has integer values in it, and they stand for different elevations, right? And based on those different elevations, you want to find out how much rain would be trapped in the gaps between those elevations, right? It's not simple enough. So let's get a visual representation of the problem here. And so you see the correlation between the values and the heights of the different elevations. For the purposes of this video, we're going to call these different indexes columns with the column heights. That way we can determine the amount of rain water that would be trapped in these gaps, right? So as a problem, humans can very easily find the patterns between here. So like this gap would be filled with water, these four gaps would be filled with water, and then you have the single gap would be filled with water. But one thing that's not apparent when looking at this is how the edges react, right? This is kind of like where the analogy starts breaking down of trap and rain. So prior to index 0, we have a bounds that is unknown, and after index 11 we have a bound that's unknown. And because of that, the way this problem works, you can't hold rainwater at this index, and you can't really hold rainwater at this index either, because we don't know what the height of the wall is on the bounds, outside bounds, which at this point is null or nothing or some garbage value that the system has. Okay, so now that we got a visual representation and we understand what we're given, we can kind of think about, let me describe the different ways that you can solve this. There is a faster way to solve this that I'm going to show you, but I think the way that I'm going to show you, even though it is slower, it's a lot easier to understand. And once you get an intuitive sense of what's going on, you can then move on to the quicker way of doing that. And I'll do another video to describe how to do that too. Okay, so let me kind of go overview. So yeah, like I said earlier, this is how the water pools, but how this algorithm works exactly. So basically, we're going to get 2 points, or 2 boundaries, and then we're going to iterate between the space between the 2 boundaries, and we're going to find out how much water is in those spaces. So for the instance, we have 2 pillars. One is height 2, one's height 3. And then you're going to take the minimum of those 2 values, because water will pull at the lower locations, and if you get more water than in the lower locations, you'll just get overflow and the water won't stay there. So you take the minimum of those 2 boundary values, and then you iterate through the space between them, and you find out how much water can be held there. What's different though about this is because we have to start at the beginning, there's really no space between the 2 boundaries, and you'll see it's not as intuitive at the beginning as it is as we get toward the center. So you have to bear with me early on, because we need the information at the beginning in order to get like the tallest column that we see at the beginning. And even though you won't see water pooling at the beginning, we need those values. So like I said, it'll get more intuitive as we move from the left to the center and then to the end eventually. So let's get some values here, and let's look at some code. So obviously we need to iterate through the whole thing at least once, and we're gonna do some sub iterations to backtrack a little bit and get some values. But we just do some housekeeping, and we're going to iterate from the beginning to the end. I'm calling here length of field is the end, which is the value is 12 for the length. And then we have these 2 values at the beginning, which is the current column that we're on and the tallest column we've seen. The tallest column we've seen is index 0, because we haven't seen anything else but 0 when we start. And the current column isn't actually index 0, it's actually going to be index 1. We don't need it at index 0 because that would be redundant. We're going to iterate forward because we already have access to index 0 from the tallest column we've seen variable. Okay, so if we follow this for loop, let current column equal second column, which I'm just calling index 1. So that's true, and then we want to make sure that when we eventually get to the end or the length of this field, that will stop. So that's all we're checking there. If height of the current column is greater than height of the column to the left. And so the reason we're checking to the left is because that's the only that's the only time that there's potential for water is because we're iterating from the left to the right. So when the right is taller than the column to the left, when the column on the right is greater than the column to the left, then you have potential for water to pool. And so we'll move on forward from there. So if that's true, and in our case, it is true. Index 1, the column at index 1 is greater than column at index 0, which is 0. And then we're going to set our water level. Like I said, the water level is the minimum between two boundaries. So, like if for instance, as I said earlier, just this column 3 versus like column 7, you want to take the height of column 3 because it's lower than column 7. So we're going to return to 0 because we're talking about the tallest we've seen, which is column at index 0, and the current column, which is the column at index 1, and the lower of the two is 0. So once we've set the water level, which is 0, we check to see if we set the iterator to right of the left boundary, and the left boundary is always going to be the tallest that we've seen. So for instance, at index 3, the iterator would be index 4 because that's the space between the two boundaries. At the beginning, like I said, it's not intuitive because it's going to just push to the right, and it's going to be the same as the current column. And you'll see that just forces us out of the loop, and we can start moving current column over to the right, so we can actually start doing some calculating. So we set it to the right of the tallest column we've seen, and then we're going to check if the current column is greater than the column that we're checking, which is not, so this is going to bump us out. After we do that, we want to reset the value of the tallest column we've seen. So the current column we're on is column at index 1, which is height 1, and the column at index 0 is height 0. So we're going to go ahead and update that and say that the tallest column we've seen now is the column at index 1. Okay. So we go back to the top. We're gonna push forward. We're gonna push forward, iterating through the array. So we're gonna move the current column over to the right. Then we're gonna check after we move it over to the right, it isn't at the end of the array yet, which is not. So we'll go ahead and check if the height of the current column is greater than the height of the column on the left. In this case, it's not, so we'll just exit it out completely now, and then we'll iterate forward. And then after we iterate forward again, we check to make sure we're not at the end of the array. And now we're seeing if this height of the current column is greater than one on the left. In this case, it is 2. One on the left is 0. We're at this one is 2. So, and now you can see that the last column that the last tallest column that we saw was at index 1, and that was height 1, and our current column is at height 2, right? So now we have some space between our two boundaries that we can actually start counting water at. And in addition to that, moving forward, now we're going to set the water level, right? And so when we set the water level, we're just taking the smaller of the two boundaries. So column at index 1 has a height of 1. So that's the smaller of the two, right? So water level is 1. So now we can actually go through our for loop that goes through and calculates water, right? And so that iterator is going to be set to the right of the boundary of the left, right? And the boundary of the left is the tallest column we've seen so far. So now you can see check column for water is actually between tallest column we've seen so far and our current column, right? So we went ahead and set that, and then we're going to check if the height of the column that we're currently looking at is less than the water level, which in this case it is. Our height is 0 and water level is 1. Then we're going to go ahead and count a water block at that point. So water block count equals water block count, which is currently 0. Let's see if you see that there, which is currently 0. And we're going to go ahead and do the difference of the height of the ground and the height of the water level. And so that's going to return a 1. And here's something different. Probably just should have brought it up a little bit earlier, but that's okay. Uh, After we count that water block, we're actually going to fill it up. So we get rid of it, and you'll see why that's the case when we get over to like index 6. So we'll fill it up with dirt, right? And before we move forward, I'm going to kind of it's a little weird that we're filling it up, and so I'll explain why when we get to index 6 why we're filling that up, and it'll make a little bit more sense when we get there. Okay, so then we reset the tallest. So is the current column greater than the previously tallest column? And it is, because the current column is 3, right? So we're going to update that by moving that over to the tallest column, and then we're going to push over to the right. So now we're gonna iterate forward, and we're still haven't reached the end yet. So we'll move through there. But again, this column is not bigger than the one on the left, so we'll just jump back out and we'll iterate forward again. And again, this one is not bigger than the column to its left, so we'll iterate forward again. So here we are. I'll tell you. I'll explain a little bit more when we get here. And this is where we're at. Our current column is the column at index 6, and the tallest column we've seen so far was the one at index 3, which is height 2, and we're at height 1, right? Okay. So you see, when we're going to get the water level here, that we're going to take the minimum of the two columns, right? The current column and the tallest column we've seen so far. The minimum of that is 1, but you see that the water level above this is at 2, right? We know that the water can pull that high. The thing is, we haven't seen the column at index 7 yet, right? So if we were to take the water level between the column at index 3 and the column at index 7, we take a minimum, the water height would be 2 at that point. And then if we iterate between those two values, then you'll see that you will do, at index 4, you'll count 2, index 5, I'm sorry, at index 4, you'll count 1 water block, at index 5, you'll count 2 water blocks. And that's a problem because we're already calculating the water between those two indexes, index 3 and index 6. And that's why we're filling it in. So we calculate the height between those two up to the water level, and when we fill it in, and make sure we won't count it again when we find a taller block, basically. Okay. And if you don't understand that, you'll just kind of look at what's going to go on as we're filling it up, and it'll kind of make a little bit more sense to you. So we're checking that we haven't reached the end, which we haven't. We check that the height of the current column is greater than the height of the column to its left, which it is. Then we set the water level to the minimum of the tallest and the current column, which is 1. And then we set the iterator to the right of the tallest that we've seen so far, which the iterator's at 4 now, right? But remember that the water level is at 1. You see the ground level of this is at 1 too, so we won't be calculating water block at this point. So and then now we're just checking that we haven't reached the right boundary. So if height of the column that we're checking water at is less than water level, which is not, they're equal. So we'll go back to the for loop and iterate that forward. And now here it's true, right? So the height of the water level is 1, and we're currently at height 0. So we want to check that the current column of water is less than current column. Yeah, so we're not at the right balance yet. So let's move forward. And then we see if the height of the current column is less than water level, true. So we'll go ahead and add a block of water. So we're at 2 blocks now. And now we're going to go ahead and fill that block in, right? Okay, so let's move forward. And now we have reached the right bound. So this is going to go ahead and bounce out. And then we're going to see if we're going to reset the tallest we've seen so far. We're not, because we're at a height of 1, and the previously tallest was at height of 2. So we'll just go ahead and move forward, and then we'll go forward. And this is the interesting part. You know what I mean? You actually see these 3 get filled in with this algorithm, and you'll see that we don't count the reason we filled in the space at column 5 was so we didn't count it twice. Okay, and we want to make sure we haven't reached the end, which we haven't. And the column that we're at now is greater than the column at the left, so we'll go ahead and we'll reset the water level to 2 because the minimum of the current between the current column and the tallest column we've seen so far is 2. And so now that's the water level set to 2. We're going to put our iterator to the right of the left bounds. And then we will check at that point that we haven't reached right bounds yet, which we haven't. And then we're going to make sure the water level is at 2. We want to make sure that the height of this is 1. And so there is a difference. So we'll go ahead and add that difference to the water blocks. And then after that, we'll fill it in. And then we will go ahead and move over to the right and we'll do the same. We will check that we haven't reached the right bounds, which we haven't. We will check that if there's a difference between the water height and the current height. And there is 1, and we'll add that. And then we will move to the right again, check that we haven't reached the right bounds yet, which we haven't. Make sure there's a difference and go ahead and fill that in. All right, and we'll move over to the right and we'll go ahead and jump out here because we've reached the right bounds. And then we will see if we need to update the height, the maximum, the largest height that we've seen so far, which we do, because this is height of 3 and the previous one was 2. So go ahead and update that. We'll iterate forward, make sure we haven't reached the end of the elevation yet, which we haven't. So now we see that the current column is actually smaller than the column to its left. So we don't have to calculate anything. Go ahead and iterate forward. And again, this column is less than the column to its left. So again, we'll just iterate forward. And now finally, we're at a place where the column height to the left of this is actually smaller than the current column. So we'll go ahead and see if we can calculate, which we can. We'll go ahead and update water height. So we have 2 heights, right? So we have the tallest we've seen so far, which is 3, and the current column, which is 2. And we take the minimum of those 2. And so the water height is now 2. So we have water height of 2. And then we set our iterator between those 2. And we see here that the current iterator is currently on a column with height of 2. So there's no difference at that point. So we don't need to add a water block. So we'll go ahead and iterate forward. And here we see there is a difference between the water height of 2 and the current height of 1. So we'll go ahead and add a water block. And then we'll go ahead and fill that one in. And so after that, we can just iterate forward. And this, we want to see if this is taller than the one to its left. And it's not. Oh, sorry. We want to see if we have to update the tallest. We don't, because our tallest is currently the tallest of the array, so that's not going to change anymore. But this current column isn't taller than the one to its left, so we're just going to end up jumping out completely. So we're at the end of the array, and then also this column isn't taller than the column to its left, so we're going to end up just iterating to the end at this point. So now our current column is outside the bounds of the array, so we're basically done. And this will jump out, and here we're returning the water block count of 6. So we have our total water block count being returned, which is correct. Like I said, this is the longer way of solving it. There is a quicker way, which I'll do 1-4, which has to do with 2 pointers, and that's done in O of n. So this one is a little bit slower. So yeah. So if you have any questions, feel free to reach out to me, and yeah, see you with the next problem.